So welcome everyone to Atacama. We are really glad that we can host this meetup, and thanks to Jiří who is organizing this. We are big fans of communities. So today I would like to speak about Kotlin, which is quite surprising for those who know me. Vašek is nodding. And the reason why it is surprising can be summed up by, do you like something else than Java? I'm known for being old man yelling at things. Disclaimer, everyone expects some Kotlin hate today, and I have to disappoint you, it won't happen. I am actually a really positive person, so it will be about learning from past to utilize it in Kotlin, actually. So no hate, except 1 or 2 slides. We'll have to click it. So as I mentioned, I am the old man yelling at things. My name is Dominik Moštěk. I'm 15 years in, let's say, professional software development. I tried many companies, including big corporations, startups, and now I'm engineering manager here at Atacama in a team which is fully Kotlin. Also thanks to Vašek, our Kotlin guru. I was raised by the JVM ecosystem and Java language. That's why I love it. I love clean coding, clean design, doing better software. And as I said, I like to yell at things. Currently, as an engineering manager, I like to yell at my team, mostly. I usually start my presentations with quoting some clever paper. So this time it will be this paper called No Silver Bullet, Essence and Accidents of Software Engineering by Fred Brooks. And notice the published date. It's 4 years older than me, so that's quite interesting. And even though you haven't read that paper, you probably know one of the most quoted parts of it. The author laid out the terms essence and accidents in programming. By essence, he means the problem we are solving. We usually call it like business requirements. That's why we are here, why we are employed, to solve problems. On top of that, there are accidental problems. And that's our hardware, coding, even meetings, all the Scrum ceremonies. That's extra. And the goal should be to do as little accidents as possible in favor of solving the essential problem, of course. What is less known from that paper are those parts, because he states that there are already many solved things in the part of the accidents. One of them is, you don't have to read it, I will sum it up, introduction of high-level programming languages. It's from 1986, so by that time, it was still quite common to code in low-level languages like some machine codes, assembler, and so on. So introduction of more high-level languages really removed a lot of accidental complexity in software engineering and allowed more progress. He's quite pessimistic also about development, because he says there's no single development in technology or management that will promise us even order of magnitude improvement in productivity, reliability, or simplicity of software development. Even though he's pessimistic, he also says that there are some things he thinks that will make huge impact in following years. One of them, you probably know, buy over build. That's a thing in most companies. Rapid prototyping, also adopted. Growing software organically, more or less. And the last thing, identifying and developing the great conceptual designers of the rising generation. So he considers like coding itself, like a programming language, a solved thing. And he thinks that we can have improvements in code design, not the syntax or the language itself. So now you probably know where I am heading. There is more paragraphs about having the great designers. He wants to focus on persons, not committees. He specifically says that. So individuals are the source of the great design, not any committees, not some architectural groups or whatever. You, as individual programmers, are the source of the great design. So how to actually, and that's the point I want to focus on. So how to actually grow and design good software. So what are the properties? It's of course very easy to understand. It supports growing, so adding over changing things, because change leads to errors, of course. And those add-ons and changes are really isolated, so the blast radius of that change is kept low. Another thing in my presentation is that I try to sneak this picture in every of my talk. So task completed. It's here because I believe that solid is actually the core of great design. So learn solid. So now to the Kotlin part. Does Kotlin help in creating better design? Does it somehow fit into that hope for the silver? That's the controversial part, and the only one. And that's why everyone thinks I hate Kotlin. It's not true. I like Kotlin. The problem is that it doesn't deliver the thing I expect it from it, like that huge boost in productivity or simplicity of the programs. So I don't really see the difference between Java and Kotlin, because we can have good design in Java as well as in Kotlin. So I often hear things like that Java does not have that feature or that feature, or that it is hard to do that thing in Java. And my usual answer to that is that it should be that way. The problem is it's not a bug, it's feature. If something is hard to do, it maybe shouldn't be done at all. So that's what I usually criticize, that we are focusing on improving things that we shouldn't be doing in the first place. I've chosen some random things from Kotlin that are oftentimes mentioned as an improvement over Java. The order is random. The things also were chosen randomly. I just want to illustrate the point about it and to learn from the mistakes we did in the Java ecosystem and not to repeat them in our Kotlin code bases. Just a moment. Šárko, můžu tě poprosit o pití? Jo, děkuji. Vodu jenom. Data class, which is usually really a favorite thing. Everyone is waiting for records in Java. And I must say, like, this is of course better than this. Like, this is bullshit. But maybe it was hard to write because it shouldn't be written in the first place. Why? I have some examples. They are really stupid. Sorry for that. But they are just for illustration. So this is a typical example of such code. We have some user entity, and we do some logic on it. So something wrong with that? Yeah, nothing, probably. When we move to testing, because we always write tests, of course, for everything, it's very simple test. But do you notice something? I need to put some name in the constructor, even though it's completely useless in the test. I don't use it, I don't assert it, I don't do anything about it. So we say, is that a real problem? Yeah, it's not in such a simple example, but in real life scenario, those input setup usually looks like this. It's really complicated, it's really in depth. So yeah, example might look stupid, but in real life it ends up like this. And as the software grows, of course, as change requests come, there are changes. So now I'm even utilizing the name. Again, not a problem in simple example, but the problem starts when we go in hierarchies of data. So our user entity will hold, let's say, addresses, orders. Order will hold some history, transactions, and so on. We go in depth of that graph, and then we start violating something called law of Demeter. You probably heard that already. And we start, let's say, entangling our structure into whole code base. After many years of that project, this usually leads into almost impossibility of any change in that structure without changing half of your code base, because it depends on it. There are also other problems associated with that, but that's the. So what are the lessons learned? Data class, awesome thing. You don't have to write that monstrum, but don't overuse it. Keep this structure of those data really flat. Don't go in any graphs. Don't bypass long parameter lists with data classes. It usually just hides the problem of long parameter lists, not solve it. I sometimes saw sharing data with data classes over the layers, and I'm not saying in Kotlin, but in Java, that I need something from controller to pass it to, let's say, 3 layers down to the repository. So I just add it to the data class, and since it goes through all the layers down there, I will pick it up from there. Again, sometimes it's not a problem, sometimes it creates a huge spaghetti code. What to do instead? Can utilize like pure functional programming, or go other way. Don't do anemic code. Do really attach the data with the functions, create objects. I will quote myself. I had exactly this topic as a talk on a Geekon. So if you are more interested in the topics of functions and objects and how it works together, go to YouTube, from objects to functions. Another function of Kotlin, or feature, singleton. Again, harmless on its own. You will use it somehow throughout your project. Again, seems harmless, but then someone realizes, okay, it's no longer a singleton. I need an instance of it. Do you see? I specifically put packages there so it illustrates that the change is everywhere. The blast radius of the change has increased. Maybe writing singleton in Java was hard because it shouldn't be done in the first place. And the thing gets worse when I need to pass some parameters into that instance, because I need to then change the whole call stack to get there with the parameter. So lessons learned, don't do singletons in code. Use DI containers for it, or factories. And I expected a lot of smiles when I mentioned factories, because yeah, Java developer, he needs factories. Yeah, I like them. They are there for a reason. Or one not that typical solution, use domain-driven approach, because that teaches that nothing is created out of thin air. Usually there is some origin where it begins. So in this case, create the objects from that origins, from parents. It looks kind of like a factory. You might call it like that. Just a side note. Value classes, my favorite. When I learned that Kotlin will have something like value classes, it was a killer feature for me. Like I was like, okay, forget about Java. Kotlin is new thing for me. I will use it. Then I was quite disappointed, and the reason is I will switch to Java. And one thing I hate about Java is exactly this. I have some input to my function, integer, string, whatever. And when I call it, I need to get that integer, and I need to get it instantly, like immediately. I don't have an option to evaluate it somehow lazily, or I can, but it's not that easy. Or I have to change the syntax completely of my compute function. I need to use supplier of that integer or some other way. Okay, that's a solution, but I don't like it because I had to introduce another accident into my solution of the essence problem. I need to introduce the supplier. So I was hoping to get something like this. This is Kotlin-like, but it's a pseudocode. How I imagined that it will work. That I will have a value class that will act as an integer, and I can use it where integer can be used, and it will be evaluated somehow lazily. So this was my expectation, but yeah. So value classes, again, I would mostly avoid it. I tried it, and it didn't lead to like decreasing any blast radius or increasing maintainability of the code base. So I wouldn't use it. I would still stuck to functions or to custom types. Extension function. I hope the video will work. It's my favorite. Like, it's a really cool thing, and just see where we got. Like, and it's a very simple project with a low number of dependencies. The video has like 40-something seconds. So this is a just extensions function on strings. Like, I expected Kotlin to be more like readable and and boost my productivity. I don't want to go through such lists of extension functions. So yeah, extension functions, I really like them actually, but now I don't know how to switch to next slide without running the video. Yes. So lessons learned, it's cool, just don't overuse them for everything because it looks cool. I'm more like composition of the behavior using constructors. This is not my code, this is stolen from and on purpose stolen from Yegor, I don't remember the surname. He's really, let's say, OOP purist. So he creates this instead. And that's just personal. I like this more. Operator overloading. I haven't expected to see operator overloading in 21st century, to be honest. When it's a really powerful feature, I have to say, like awesome and powerful. But with great power comes with great responsibilities. When I was writing in C++ and I learned how to overload operators there, I did it all over the place because it's so cool. But the problem is then you actually decrease the readability if you overuse it or use it somewhere someone does not expect it. I usually must really like search through the code to understand that there is something overridden that I didn't expect, because who expects like classes to be negated or something like that. So my lessons learned from operator overloading is never, 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 ever. I am sure that you can find some really good example where it helped. Yeah, of course, there's always an exception, but for me, that's a no-no. Getter-setters, that's my favorite topic in Java. Again, we made it really simple to write it, but that's another topic or another thing that we shouldn't have been doing at all. So why to improve the syntax of it? Why we shouldn't done it or do it is what I was talking about at the beginning. It doesn't mean that when you use it, it will immediately lead to violation of law of Demeter, but it kind of attracts that thing. It invites it to your code base. So lessons learned from getters and setters: encapsulate behavior, don't expose your data, or choose functional programming. Like choose between those two, stick to it. And this is actually my last slide. As I said, I will disappoint anyone who thought that I will hate Kotlin or start some flame war. I actually like it. Just learn from the past. So use it. Learn from the past. But if you want to see real productivity boost or simplicity used in your code base, don't expect any new language to deliver it. The fruit lies in the not in the syntax, it lies in the design. So invest more into design if you want to simplify your code and make it better. Again, last quote from the Brooks, from that paper. We still make syntax errors, to be sure. It will be there, like syntax will be always weird. But it's fast compared to the conceptual errors we create by bad design. Yeah, and so that's all. Thank you for listening.
Kotlin and sealed classes, what's your take on that?
I saw Vašek used it really cool when defining our API scheme, or how to call it. He actually had a great presentation about it 2 meetups ago, I think. So yeah, browse in the archive of Kotlin meetup. So again, I think it's a really cool use of it. But otherwise, I never needed them. So I think there are other solutions, but I have seen cool use of them. So
yeah, I think it's handy for like to avoid like throwing exceptions.
Yeah, that's what we are using them. Like we return like union types to our API using sealed classes.
Huh? What frameworks are you using with Kotlin?
Okay, the question was what frameworks we are using. It's standard stack, Spring Boot, Juke. Do we use anything special there? I don't think so. Guys are using Cotest for testing. I'm not a fan of that. I use JUnit and SRJ. So.
Are you using killings from Spring Web Flux if you are trying to write functional ways or?
I have seen them in our code base. I don't use them. I think Adam uses them, but not much, to be honest. Because we don't have, like, even if we would use them, we wouldn't use them end to end. So it doesn't make sense, like, to have them just in one place.
Other question?
Did you use Project Lombok?
Lombok? That's my favorite question on to candidates on interviews. What they think about Lombok. Yeah, I actually, that's one thing I really dislike because it makes doing wrong things easier. And of course, it's good when you have to use it because some frameworks like Hibernate or some J2E things, they expect the getters and setters to be in place. So if you are in an environment where it has to be done, then use Lombok to simplify your work. But if you are writing something new where you don't need it, then I would avoid it.
So thank you for your questions. Now we will take 10 minutes pause and we will be continuing. Thank you again.
Thank you.